Assalamu alaikum. Bismillahirrahmanirrahim. Rabbi shrali sadri wa yassirli amri wahlul uqdatam min lisani yafqahu qawli rabbi zidni ilma. Okay, today we are here to discuss one very important chapter for paper 2, that is chapter 7, algorithm design and problem solving. Before we proceed to the chapter, first of all, what we need to know is what are the requirements of the key objectives that we need to study here. We are going to revise the stages in program development lifecycle, shorten it as PDLC, which are analysis, design, coding, and testing. We'll talk about computer systems and subsystems. We'll also talk about computer program decomposition and abstraction also. We'll talk about the methods that are used to design and construct solutions to the problems, the purpose of an algorithm and the processes involved in it. We are going to talk about standard method of solution, which are totaling, counting, finding maximum and minimum, average, linear search, and bubble sort. And be very, very attentive, because the question can come in the paper asking you that which standard method of solution is used in your given code. Validation and verification, very important with respect to your exam, will be discussed, inshallah. Use of different types of test data, which is going to include normal, abnormal, extreme, and boundary. And we are going to talk about the documentation of a dry run using a trace table. So when we talk about testing, we are going to use the test data to see the impact of different variables or different situations at different time intervals. Writing, amending, identifying, and correcting the errors is also going to be a very important thing in the flowcharts, programs, and pseudocode writing. So this is going to be just a brief discussion. And since you already have attempted a few of the past papers, so I think that will give you a very clear idea of how will you go about, inshallah, for your inshallah in your exam. Moving to 7.1, program development lifecycle, which we shorten as PDLC. So these are the 5 stages, and for you people, you need to know analysis, design, coding, and testing. Although maintenance is also a very integral component of the PDLC stages, but let's talk about analysis. The process of investigation using abstraction and decomposition to specify what a program does. Whatever the program is performing, we use abstraction. By the way, do we remember what is abstraction? The definition. Abstraction means ignoring unnecessary details and only taking the whatever is required. That is your definition of abstraction. So just note it down. You need to know the definitions of the two key terms that may come in the paper. So just know what they want you to write and the definition I've told you. And decomposition is breaking down the main task into subtasks till each subtask is performing an activity. This is your decomposition, the way we talk about in real life also. So these are the 2 things that we talk about with respect to analysis, which is my first stage of program development lifecycle. Then is design, and we use structure charts, or structure diagrams or flow charts and pseudocode in order to design, or in order to talk about that how can I make the system work, will be shown on a piece of paper with the help of either structure diagrams, or we use flow charts, or we use pseudocode writing. So these are all the means that we use in order to perform the designing. Then the next stage is coding. As you know, that is dealing with writing down the code using a programming language. And then we talk about the iterative testing. By the way, whenever you write the code, when you inshallah will be learning programming in your later life, then along with the programming, we talk about the testing. We keep on testing the data to see that how my program is responding. So this testing is again a repetitive task, and this carries on even when we are designing a program, and that is why it is mentioned as iterative testing, because when you are coding, you design and test also at the same time. Later, once we are done with the program development, coding is done, then we go for the actual testing, and that is testing the completed program to make sure that it works under all conditions. It is free of all types of errors. And just reminding you, if you remember, we have talked about 3 types of errors. The first one is syntax errors, second one is your logic errors, and third one is your runtime error. So the testing is done just to remove any sort of syntax, logical, or runtime errors. Lastly, it's not a part of the syllabus, but still you need to know that what is maintenance basically. Maintenance is just the last mean, and then we just talk about that how the, if for example something goes wrong, then the maintenance is going to be there to see that how the program will be corrected to give the maximum benefit to the end user. Now, the same activity that we had been doing for our paper one. So you are given a sample question, and then we are going to discuss sample high-level answers, and I'll also show you sample low-level answer also. So you can differentiate yourself that why the answer was high-level and why the answer was low-level. PDLC is divided into different stages. Analysis is the first stage. Describe the purpose of analysis. Identify and describe two other stages of the program lifecycle. And here we can see sample high-level answer. Analysis is used to investigate the problem that requires a solution and find out what program needs to do to provide that solution. That is a very brief and concise description of what analysis is. Two other stages, a student can say design, encoding, he can write testing also. But since they have written this design means, along with writing down the terms, you have to describe them also, document the task required for the solution using structure charts and pseudocode writing or flowcharts. And coding is writing the program, that is using a programming language. So this is how the whole question will be answered, and then the tips. By the way, my main concentration is you people noting down the tips for the best answers to be written. Part A of the question asks for the purpose. So your answer must state why analysis stage is required, not what actions are to be performed. See, this is what you need to be very clear about. The question was only asking you what is analysis doing. So this is why they have mentioned that the student should not be now. Students should not be writing down about abstraction and decomposition. And the low-level answer is C. A system analyst will use interviews and questionnaires to find out what is needed. I mean, completely out of question. The stages of program development lifecycle include analysis, design, coding, and testing. There is lots to do as the programs need to be written and fully tested. I mean, you can see for yourself, you, although are a student, but I think now you are in a position to identify that this is completely a low-level answer because that is not meeting the requirement at all. And then the teacher's comments are here. And then you can see part of B of this question involves identify. This means your answer must either name the two stages of the PDLC or clearly identify each one with a short statement. Not too much of the description, but at least depending upon the marks, we decide what we have to write. The first answer would gain full marks since there is a clear description of the purpose of analysis. Two of the stages of PDLC have been identified and described with each description clearly shown for the stages required. The second answer would gain 1 mark for part A since the statement analysis is to find out what is needed. Partially describes the purpose of analysis, including the methods used, answered a different question about how analysis is carried out. See how it's carried out using the means is going to be forming another question. For part B, all the stages of the cycle are identified, not just the two required. See, this is what he has done. And besides this, is the description of this actions required, but is unclear which stage these apply to. A maximum of 2 marks could be awarded. So just to be, maybe they have awarded the mark because the child has written properly. Okay, are you clear about this? Yes, children. Any questions regarding this? So you have any question, then you can ask me right now. Ji, children, are we clear about this completely?
Yes, miss.
Okay, great. Is my voice completely audible? Okay, now, moving to the next topic, we have also talked about abstraction decomposition. Please note them down also because this can come in the paper. Computer systems, subsystems, and decomposition. Now, what is computer system? It is made up of software, data, hardware, communications, and people. This again is like something that can come in the paper. Talking about this, the parts. The parts are software, and you can see software, hardware, data, communications, and people. Okay, so because without any of these components, you will not be able to get the task done. That's why these all are important for making a computer system. And then decomposition, and they are Each computer system can be divided into a set of subsystems, and each subsystem can be further divided into further subsystems until each subsystem performs a single action. This is a very clear and up to date, like up to a very concise and clear description of what the subsystems are doing or the computer systems are doing. Any problem that uses a computer system for its solution needs to be decomposed into its component part. These are input, processes, output, and storage. Now, being very clear, this has come in one of our papers. How do we decompose? We perform decomposition by finding out that which are the inputs to our requirement, which are the outcomes, which are the processes that are being performed, and what data will be stored also. So here, this is one question has come in one of our papers where we were asked that what are the stages of this decomposition. So just be clear, then you need to talk about you will decompose into inputs, processes, outputs, and then storage. Clear to everyone? Now moving to the next one, and that is structure diagram. Structure diagram is going to show hierarchy of how the computer systems are going to be divided into a set of subsystems. And you can see here, system 1, system 2, system 3, subsystem, and then they are further classified into subsystem 1, 1.1 and 1.2. And that's perfectly okay. You may not have any other subsystem for 2 or 3. That's perfectly okay. That is a very small description. And again, you need to know the definition because that can again come in your paper. Now moving to the next terminology, flowcharts. And for these flowcharts, you need to know the flowchart symbols. What is the definition of flowchart? It is showing the diagrammatic representation of solving the problem. So again, the same problem solving, but here we are not using the written code like pseudocode. We are simply using the symbols. We are using the simple diagrams to get the task done, and that is going to be called a flowchart. By the way, again, question can come in different styles, but let's talk about that what the symbols that we need to know. The first one is terminator. The name it's terminator, and it's meant to hold a start or a stop. So your flowchart starts with start and it ends with a stop. And it is used at the beginning and end of the flowchart. Then we have a process, and this process is just a simple rectangle, and it is used to show actions, for example, when values are assigned to the variables. This is one example of usage of the process symbol, of the process flowchart symbol, and you can even talk about that this same symbol is also used for performing any sort of calculations. So when any sort of calculations are required, then again we go for the process symbol. Then input and output, they both are done in the same box. Input, again you can see the keyword input is written in capital, and then you write the variable. By the way, this is somewhat similar to what you have learned as far as the pseudocode writing is concerned. Then decision is shown through this box. And here we can see there's no word if written here. You simply have to talk about the condition, and it may involve an and and or also perfectly okay. But this is how we write the decisions, and it is used to decide which action is to be taken. This can be used for selection and repetition. There are always two outputs from a decision. And these are certain things that we need to be careful about. Again, just thinking right now, thinking out loud that maybe a question can come in the paper. Have given you some descriptions and they're asking you to draw the appropriate flowchart. That's perfectly okay. That's perfectly possible, but you need to be clear about. Now we have the flow lines, and definitely without the flow lines, the flowchart is incomplete. One more box, that is let me draw that one. And then let's see how many of us can recall. This is a rectangle. And then now I'm drawing true two vertical lines here. So what is this denoting, if you can recall? Yes. How many of us can recall this symbol? What is this for? It is for subroutine. And remember, subroutines mean like your can anyone of you please recall what is subroutine? Subroutine includes procedures and functions. So this is what the main thing is, that you can use any of it to represent the the subroutine. So this is what you need to know because it has come in the paper and it can again come in your paper. So just remember this is the symbol for your subroutine. Now moving to pseudocode, and before that, it's a simple method of showing an algorithm. It describes what the algorithm does by using English keywords that are very similar to those used in a high-level programming language, and it is composed of meaningful identifiers. One thing that you need to know is identifiers mean what? Your variables are identifiers, your array names are identifiers, your procedure names are identifiers, your function names are identifiers. So everything that you are using for your own for your own self in your program, that is called an identifier. Includes variables, constants, array names, procedure names, function names, they all are identifiers. So whenever you are making use of these things to write a program that will be similar to a programming language, then that will be called pseudocode. Pseudocode means a false code. Now moving to one important thing that I want you all to please note down, because it has come in the paper and can again come in your paper also, talking about the different types of operators. When it comes to mathematical operators, then you talk about add, subtract, multiply, divide, raise to the power, and the group. So these are your mathematical operators. Just be clear that considered to be mathematical. They can ask you to talk about, explain what are mathematical operators. They may ask you to give an example, and you can simply, if I ask you, give an example of addition. So how can I give an example of addition? Just asking you. Can anyone of you please help me out with the example?
It's like you can put one.
Even if I say simple, C equals to A plus B, that's simply an example of the same. No worries at all. You simply write it down. That's perfectly okay. That is an example of your addition. Okay, and that is assignment also definitely, but along with that, that is addition, multiplication, subtraction, division, and raise to the power. And this is the power sign where you mention the power with the help of this caret symbol. And then groups are shown with the help of the simple brackets. So these are your mathematical operators. Now moving to a few pseudocode statements. And through that, let's see that how many of the pseudocode statements we can recall. Assignment. And remember, this is called the assignment operator. A value is assigned to an item or variable using the assignment operator. And please see for yourself that the assignment operator is always pointing towards the left-hand side for the variable. And there is only one variable written on the left-hand side. Because you may get a question in the flowchart debugging or pseudocode debugging, or maybe the thing can come in your database also. The debugging questions can come in your database also. So cost equals to 10 is written as cost assignment operator 10. Then you can see selling price is equal to or assignment operator price plus tax. That is also assignment. Then you can see condition checking that is done through if then else and if you have two conditions maximum, if you have two options maximum, then you go for if, and this is an example. If age less than 18, then output child, else output adult, and if. So this is a simple structure that we talked about in, I guess, in the class yesterday also. So any question regarding if, how do you write if, then, else, and end if. Then conditional statement 2 is your case of, otherwise, and case. And here we can see how do you write it. Case of variable. In this case, the variable is grade, and we are simply checking the three options A, B, C. Otherwise is going to be used when all the above options are incorrect, and then it will be moving to otherwise. A means output excellent, B means output good, C means output average, and otherwise output improvement is needed. And then we finish it with an end case. Remember, if is ended with end if, and case is ended with end case. Okay, any questions? Now moving to the one thing that you need to remember is the use of the colon sign to indicate the condition and the statements. And one more thing is statements can be more than one also. That's perfectly possible. You do not have to think that statements are always going to be like only one statement. We can write as many statements as you want to. And please be very clear about these things because they can really help you in your scenario-based questions. So again, a suggestion, if you have a number of options and you want to make your program, your code more efficient, when you have a condition checking statement, then always prefer to use a case rather than using if. Iteration, there are three statements. For to next is a count control loop. Repeat until is a post condition loop, and while do and while is a precondition loop. So let's talk about them very quickly, briefly, so that you can recall. For to next, where the variable is set, and so this is a variable and its data type should always be integer. Please remember, this counter, you can have any variable, but this is a variable. But one thing that you need to be very clear about is whichever variable is used with for, it should be an integer value. It should be an integer variable. And then again, the use of assignment operator. Sometimes I've seen a number of students forget to put the assignment operator here, although we are reminding them repeatedly, but still, I don't know what goes wrong with them. So please be very clear that this is very much an integral part of the syntax. You use assignment operator and then you mention the beginning to and then the end. One more term that you can include, this is again a part of the for syntax, but that is optional, is the use of the word step. Now, let me write it down here for you people. But this step value is an optional value step. And then you mention the number, that how many values do you want to step. Whether you can go in the reverse order, the forward order, they both are possible, but you need to mention the keyword step and then you mention the number. Now here, the task is to work 10 times and output an asterisk, a star, that's all. And next counter, again, a reminder, the use of the variable with next is optional. You write it, that's perfectly okay. You don't write it, still that's perfectly okay. So just a few reminders, if they have given you a structure which is not containing a variable with next, so do not consider it as an error. It's completely possible. Repeat until is used when the number of repetitions is not known and the actions are repeated until a given condition becomes true. Action is this loop are completed at least once. So this is a description that can again come in your paper. Although we have been talking about these things repeatedly in the class, also that repeat until works when condition is false. It stops working when condition becomes true. It is working at least once, and when you do not know the number of repeats, then you perform either the task with repeat until or we use a while loop. Then counter, you can see counter equals to 0, repeat, output asterisk, counter equals to counter plus 1, and until counter greater than or equal to 10. So the moment the value of counter becomes equal to 10 or above 10, it will stop functioning. Okay, now the same thing is done with the while loop also. It is used when the number of repetitions or iterations is not known and the actions are only repeated while a given condition is true. If the while condition is untrue, and then the actions in the loop are never performed. So if they give you such a question in the paper, then please be very clear. At least once is going to be your repeat until, may not work even once is your while. And you can see here, the condition has to be true. So if the condition is untrue from the beginning, then it will not enter the loop at all. Counter equals to 0, while counter less than 10 do. So you can see here, the condition is true. That's why it will be entering the loop. Output asterisk, counter equals to counter plus 1 and end while. Okay, now one more thing which I want you to recall and remember for the exam and forever also. If, for example, I forgot to write this line, counter equals to counter plus 1. So what will happen? Can anyone of you please recall? You've talked about this. If any one of you can please speak up or write it in the chat, I'll be really very happy to figure out that how many of us remember. I forgot to write this line, counter equals to counter plus 1. So what may happen? Your loop will become?
Miss, if you don't do counter is equals to counter plus 1, then the loop will keep on happening forever because the counter will never reach 10.
Perfect, very nice. The counter will never increase, perfect, very nice. And your loop will become a never-ending loop. That's wonderful, excellent. So the ones who have written the answer in the chat, excellent. And thank you very much for Rayan for speaking up. Aisha, thank you very much. So this is your correct answer. That, for example, if you write it down, right, that's perfectly okay. And the condition has to be the thing that you have to have written here is going to be helping out in reaching this situation, this condition. So this, if you have stopped writing this, then it will make your loop a never terminating loop. So be clear that never terminating loop is a problem. So we are not going to handle it like this. Then input is taken by using the keyword input. And by the way, let me tell you, there's another word that is read. Although we don't use quite often, But just be very clear, read and input are the same, are doing the same task, that they are there to take the input, or they are there for data entry. Then we have input student mark. And one more thing is we can take multiple inputs by using a comma in between. Output is done through print or output, and this is how you print. Your name is a message and a variable, or you can have a variable only, or you can have a message only. So anything will do. Along with this, we talk about the term nesting, and nesting means one inside the other. So when you have multiple conditions, more than two conditions, either you go with case or you go with nested if. And this is the use of if age is less than 18, then output child, else if age is above 65, then output senior, else output adult. So when I talk about you people, your people, if I enter your ages, definitely you are going to be landing into this child. But talking about me, I'll be landing into an adult. So this is how the if, else, and the use of nested if. You can see here, this is your nested if. One if inside the other one. So this is the concept, and you can see the indentation. Very, very important is the indentation. If written, then with a little bit indentation, then you write the messages or a message, and else, and then again you can see it's written, how is it written? Then you have if written, how is it written? So just be a little cautious with practice. I hope that you are already very much comfortable with this, but that is very much needed. Any questions? This was nested if, and then we talk about the nested loop. And this is going to be any loop. Like, it is not compulsory that you always have a for loop inside a for loop. No, that's not the case. You may have a repeat and then a for inside, or vice versa. Anything will do. So but just to make it simple, there is an example of handling the for loop. And so by the way, this is the revision guide. I hope that you all have the revision guide. So just doing a very quick recap of the entire chapter from the revision guide for your benefit. For number assignment operator 1 to 10, output number. For count equals to 1 to number, output asterisk, next counter. So you can see here, nested iteration is making use of two loops. The second loop is inside the first loop. So again, you can see this is your next counter, and this is your next number. So by the way, which loop will be executed more? Just a very quick recap. Which loops work more, the inner loop or the outer loop? Yes, any one of you, please? Which loops work more? Very quick recap, please.
Miss, could you please repeat the question?
Which loops work more? The inner loops work more or the outer loops work more? Iteration-wise, which one is executing more? Will this counter loop work more times, or will this number loop work more times? Inner. Thank you very much, Samia. I hope that we all remember that the inner loop works more. Iterations, like for example, if I say, talk about this one, what will happen? Number equals to 1 to 10, output number. So what will be printed? What is the first value of number? 1. So 1 will be printed. Then I say for count equals to 1 to number. So since the value of number is 1, that's why it will be printing, it will be moving from 1 to 1. The first time the value of number is 1, so that is why the value of the inner loop will be from 1 to 1. And it will be outputting only one asterisk, because this is what I wanted. Okay, this is one asterisk only. Then next counter will move it back, since the value was supposed, the inner loop was supposed to work 1 to 1 means once only. That's why the loop is now over. The inner loop is in this case now over, and it will now move to next number and will make you it will make it move back to the for number equals to 1 to 10 once again, and the value of number will now become 2. So that is why it will be outputting 2 there, and it will be then printing the asterisk 2 times, because it said 1 to 2. So the value 2 and the 2 asterisks will be printed, and this is what the job of this inner loop is. First time it worked once, now it has worked 2 times because the value of number is 2. Then it will be moving back to the next number, and then next number will send it the control back to the for number equals to 1 to 10, and now the value of number will be 3. So it will be now moving inside, and it will be working from 1 to number means 1 to 3. Are you all understanding? Making sense? So the inner loop and the outer loop. Remember, this inner loop and outer loop will be used quite often in our programming. So just be very clear about the use of these. Yes, children, are you clear about this? The nested loop. The nested loop is used in a number of examples, especially the bubble sort. Inshallah, we're going to talk about bubble sort also. And then the comparison operators. These are called the comparison operators. Greater than, less than, equals to, greater than or equal to, less than or equal to, not equal to, and this and, or, and not are here under comparison, and they're also the Boolean operators. So just be very clear about these questions because they are coming in our paper, and they are such questions which are definitely going to give you the marks. And once you understand these revision guide things, then you will be able to recall how to answer the questions also. Okay, now, a computer system can be decomposed into its component parts. One of the parts is input. Identify two other component parts. Formal methods are used to show proposed solutions. Identify the formal methods shown. So this is what they have asked you. And this is method 1 and this is method 2. Which one is the method 1 and which one is method 2? Can you identify? Maybe it can come in your paper as a 1 mark question. Yes, which one is this one and which one is this one? Come on, this is such a simple question. You have just done it. You can write it in the chat if you are thinking that speaking is not your thing at the moment. So you can just write it in the chat also. That's perfectly okay. Which one is the first one, beta? Password checker, check for 8 or more characters, check for at least 1 digit, check for at least one special character. So what is happening here? Okay, now let's see. No, they are talking about the method of what are we using here? Identify the formal methods which are shown. And the second one, which is this method and which is this method? I just want to know the names of the methods. The first one is, see, the first one is structure diagram, and the second one is your flowchart, the thing that you had been talking about. You can see for yourself. And this is what was the identification of input. Apart from input, can you process, output, storage, anything will do. Now moving to a small pseudocode that is there for you people to work on, and that is use the formal method you have identified in part B2 to show the same routine to check if the password has more than 8 characters. So this is just the requirement. You can use any of the means to write down the code, and you have the structure chart in front, structure diagram with you, you have the flow chart with you, and what isn't there is a pseudocode, and you can use pseudocode in order to perform the same activity. So this is how the questions again can come in the paper. So I mean, I'm telling you repeatedly that be clear. They may give you a pseudocode and ask you to draw a flow chart, or vice versa. They can give you a flow chart and can ask you to draw to write pseudocode. So just be very clear that this is just an example of the same activity that I was talking about earlier. So you can just simply mention the pseudocode term, and then you write down that identify another formal method that could be used to check if the password has more than 8 characters, and then you are going to use the formal method. So this was needed to be identified that you the pseudocode is missing from the two, and then structure diagram and flowcharts were there, and you can write a simple pseudocode but by using if length of password is greater than equals to 8, then accept equals to true, else accept equals to false, and end if. So this is a simple question. I that you are clear about this, and a sample low-level answer you can see here, and that is not at all acceptable because that is not the pseudocode, and they have asked you to write the pseudocode. Okay, fine. But Jazakallah khairan Kasira for being a part of this. Rejoin, and then we'll carry on with more of the chapter. Okay. Rejoin, please, all of you.